Hey guys, week 4 summary. So basically, week 4 is all about linear equations, graphing them, and things like working out the graph from the equation, so going from the equation to the graph, or going from the graph to the equation. And we can do that using the graph, using coordinates, or sometimes we're given a line that's parallel or perpendicular to the one we're trying to find out. And we'll have a look at that kind of case as well. So let's get stuck in working from an equation to a graph. Point 1. So we could have an equation something along the lines of y equals 3x minus 4. So first thing we can do, or one way to approach this, is by finding coordinates. So, and if we want to do it like a two-step process, we can find coordinates, then plot them. Plot and join. So if we do this find coordinates thing first, let's say we've got a table x and y, and imagine where we consider the point x equals 0. So this is if we're looking at our graph, something like that, and we've got our x and our y, this is when x equals 0. And so x equals 0 is anywhere along this line, right? Off into infinity in that direction, and off into infinity in that direction. So when x equals 0, what's y equal? Well, that's easy. All we have to do is put the x value into our equation. Minus 4. 3 times 0 is 0, minus 4. Y equals minus 4. So we just put a minus 4 there. So we know that here, when x is 0, we go down 1, 2, 3, 4. And so we've got a point here, right? Next, what about if x is 1? Well, when x is 1, that's anywhere along this line, right? It's going to be somewhere along here because we count 1 across, but we haven't worked out where our line intersects. So off into infinity this direction, off into infinity that direction, all is where x equals 1, anywhere along that line. And so if we say, I'll go over here, y equals 3 times 1 minus 4, then y equals 3 take away 4 equals just negative 1. So we've got negative 1 there. So we started off here, and now we're here at the coordinate 1, negative 1. And I guess I could put in that coordinate from before, which was 0, negative 4. Whoops, different color. How on earth will I ever find the original color? Is that it? Close enough. Okay, now the point here, I could point out that two points is always enough to plot a line, right? So there's a line. 2 points. We know it's a linear equation. Highest power of x is just 1, x to the power of 1. So we know it's linear because there's no x squared or x cubed or anything like that. But what about if we want to look at another point? What about if we want to look at when, just to double check, x equals 2. So we've got y equals 3 times 2 minus 4, and this is 6 minus 4, and so y equals 6 minus 4 is 2. So we've got 2, 2. So we should find that if we go 2 up, or we can start by going 1, 2 across, and then from there 1, 2 up, hopefully that's on our line. And if we've drawn everything to scale, then it is. So that's how we go from an equation to a line, essentially. all we have to do is say, pick a couple of points, 2 points. X equals 0 is usually pretty easy because you just start with your y-intercept. Y-intercept, and you notice that that's -4 there, -4 there. Easy, and then you pick another point. I like to pick 1 because that's also going to be easy. It's just going to be whatever your number is, your 3 minus your y-intercept, -1 in this case. So we just go across 1, minus 1. Super easy. Okay, 2, graph to an equation using the graph. 2a. So, what do we do? Well, first let's think about the form of the equation. A linear equation, linear form, is y equals mx plus c. And we've mentioned before, we've just got the gradient, aka also known as slope. Got our y-intercept. Then we've got our independent variable, and we've got our dependent variable. So what independent and dependent? Well, independent means it's not the thing that depends on anything. Dependent is the thing that depends on something. So, for example, hours of homework and the score you get in your test. Right? The score you get on your test depends on how many hours of homework you do, assuming they're effective hours of homework, right? Well, they could be not effective, but let's not think about that. So, effective hours of homework, your score on your test depends on that. So that's a good example. Okay, so linear form, how would we find an equation by just looking at a line? Something like that. Well, gradient m equals rise over run equals change in y over change in x. Got x, y. So let's consider a portion of this graph. Maybe this portion. Actually, I'm going to do that line in a different color. Alright? So here we've got, I'll just do it in the associate, change in y over our change in x. Okay, so this, in this case, it's going to be a negative number. The change in y, as we're going down, and then our change in x is going to be a positive number. So we're going to have a negative over a positive, which will give us a negative. So have a negative slope. And then the y-intercept is just that. So that's all we have to do. We just have to take this one, recognize that it's that, and then take this rise over run, this gradient here, this whole thing, and recognize that it's that. And that's kind of the form. So A is form. Next we could find an equation using coordinates. So 2b. So let's think about some coordinates. Well, let's use some coordinates from our first example, shall we? So what coordinates do we have? We've got 0. Let's use 0, -4, and 2 and 2. So we've got, well, let's draw them in coordinate form. Coords 0, -4, and 2, 2. Well, the question is, we've got our y equals mx plus c, Actually, if we used what was it, 1 negative 1, 1 negative 1, and 2 2, we could say, okay, is the y-intercept there at all? Can we just read it off? The answer is no. From before we could, that's why I just changed, because we had, when x is 0, we've got the y-intercept. Remember, x is 0 all along this line, we've got the y-intercept. So, do we have the y-intercept? No. So we can't just write this straight away. Not straight away. So first step, find m. Right? So how do we find m? Well, we have to look at the change in y over the change in x. We can kind of look at what's our first x, first y. We call that y1, and equals, this is an x, this is a y1. Second y, call y2, x, y, y2. First x, call x1, equals this one. And our second x, call x2, equals this one. So if we take our values, what have we got? We've got y1 equals -1. We've got y2 equals 2. We've got x1 equals 1. And we've got x2 equals 2. Now, there's a couple of different ways to think about this, but I guess one way is to say gradient equation equals change in y over change in x, right? AKA gradient equals y2 minus y1 over x2 minus x1. And this is because the y values deal with our rise. So in this case, we've got our y2 is anywhere along this line, and our y1 is anywhere along this line. So this is our change in y. We have to take our initial y value from our final y value. And similarly, our x's, x value anywhere along this line, as we were talking about up here, anywhere along here. And our final x value is here. So the total change in x is between there and there. And we take the x1 away from the x2. So we start off at x1, x1, y1, end up at x2, y2. But in this case, we actually went up because we're looking at this graph. I should actually probably do that. x1, y1, x2, y2. And obviously the graph keeps on going forever, but these are just the 2 points that we're considering. So in this case we've got m equals y2, 2 minus -1 over x2, which is 2, minus x1 is 1. 2 minus -1 is 2 plus 1. I think of this as the minus, kind of, this second one flips around and turns that into a plus, and we've still got 2 minus 1 here. So we just end up with 3 over 1 equals 3. Therefore, m equals 3. Now we can check this because this is the graph we were talking. This is the graph we got our points from. So the question is the gradient 3? Yeah. Got it. Y equals m x plus c. 3. So we know we're right about that. Usually we don't have a check like that, but we're learning, so that's good to know. Now, what about our? Okay, well let's have a check now. Where are we? So now our equation looks like y equals 3x plus c, because we know m but not c yet. How to find c? Use some points. So the point here is that we've got an equation and we know that our line has to obey this equation, right? So we know that if we choose a value of x and a value for y for this equation corresponding to any point along the line, and we've been given 2 of those specific points, if we choose one of those points, we know that the c has to be the right c. So the c has to be the right c to make the equation be correct, to make sure that this equal sign holds. And so we can put in x1 here and y1 here, and that'll give us a value for c. Or we could put in x2 here and y2 here, and that'll give us a value for c, and that c value will be the same. Well, let's actually try it. So if we can consider the ones, our x1, we can read them off here. x1 was 1, so we've got 1, we've got 3. Our y1 was -1 plus c, so we've got -1 equals 3 plus c. Take away 3 from both sides, -4 equals c. Cool. What about if we use the other point? So our other point was x2 and y2, going up here, x2 and y2. x2 is 2, y2 is 2, 2 equals 3, and so I'm just doing this. Hope that's clear. So we've got 3 times 2, and we're using the second point now, the second point, x2, y2, plus c. And so we've got 2 equals 6 plus c. Take away 6 from both sides to get c by itself, -4 equals c. So in both cases, as we expected, the c has to equal -4 for the equation, for the equal sign to hold, and for us to still be on this line. So in one case we used this point, the first case we used the 1 values, and we found that for this point to exist on the line, c had to equal -4, and for this point to exist on the line, c had to equal -4. So what's our equation? Well, now we worked out the gradient earlier, and now we've just worked out c. So equation, finally, is simply y equals 3x plus c, and in this case c is a negative, so plus a negative is just a negative, minus 4. Great. So that was our equation from before. Y equals 3x minus 4. So we just went from using coordinates, from coordinates, 2 coordinates that we chose, which were 1, -1, and 2, 2, and we went back to, we used those 2 coordinates to find our equation. So finally, in the case of parallel and perpendicular lines, to see. So, well, what do we want to know about parallel and perpendicular lines? First, what does parallel mean? I'll use a straight line. So we've got two lines, like that, got the same slope. That's parallel. You probably know that already. So this is line 1 and this is line 2. Perpendicular, we've got one line like that and another line like that, such that the angle between them forms a right angle. So what can we say about the gradients? Well, in one case, the gradient of 1 is equivalent to the gradient of the second one, and in the other case, the gradient of 1 is equivalent to, well, you know it's got to be a negative, because they're related. One of them goes up and one of them goes down, so it's got to be a negative. But is it just M2? Well, let's think about this. If we've got a super steep line where the rise over the run's like 10 over 1, say, for something to be perpendicular, it would have to sit something like that, right? Something. Let's try that again, shall we? Let's use the actual straight line. It would have to sit something like that. And what's the rise over run for this one? Rise over run. Well, that's about -1 and 10. So we actually find out that the rise over run here is 10 over 1, and the rise over run here is -1, 10. So we know that this isn't right. So what we can actually say is it's got to be a negative, but instead of the 10 being on the top, the 10 goes on the bottom. So -1 over M2. So that's the perpendicular relation. And hopefully that's meant to be a little square box there. It's not very clear, but hopefully we went along for the ride together. So what about if we do an example? So something. Well, let's come back to our first equation again. So find the equation of the line parallel. Oh, sorry. Of line perpendicular to y equals 3x minus 4, the same one we've seen before, and passing through the point 3, 5. Where to start? Well, a good place to start, always, never hurts to write down y equals mx plus c, right? And so, okay, what we know that the equation, because we're asked to find the equation is going to take the form y equals mx plus c. Now, then we can ask, do we know c? Well, we're not given a 0c coordinate. When x is 0, we've got our y-intercept. We have no 0c. We've got a 3, 5. So we don't have the c straight away. Do we have the m? Well, we do, because we've got this keyword perpendicular. And that means that we know that m2 equals -1 over m1. Now here I wrote m1 equals -m1 over m2, but they're actually the same thing, because if I have m1 equals -1 on m2 times both sides by m2, m1, m2 equals -1, divide both sides by m1, m2 equals -1 over m1. So they're the same, right? So I used it in this way this time. So m2 equals -1 on M1. So an M1 is 3. Therefore, M2 equals negative 1 on 3. So now we've got, now equation looks like y equals negative 1 on 3 x plus c. So we're at the point that we were up here before. Now the equation looks like y equals, and we've got the gradient, but we don't have the c-intercept, or the y-intercept, which is c. How to find c? Use some points. Come back down here. Use some points. So which point do we have? Oh, how convenient. We've got this one here. So 3, 5. So sub in x equals 3, y equals 5 gives 5 equals 1 on 3, negative 1 on 3 times 3 plus c. Therefore, 5 equals negative 1 times 3 on 3 plus c. I'm doing the steps to make it real super easy. 5 equals negative 3 on 3 plus c. 5 equals negative 1 plus c. And then we add 1 to both sides. So we can say 6 equals c. Therefore, equation is, well, we have our y equals our slope. Let's go back to our original colour. Y equals our slope, which is negative 1 on 3 x plus 6. Is that right? Well, here's something I prepared earlier. And you can see that our original equation, y equals 3x minus 4, is here. Y-intercepted minus 4, passing through these points. And then our new equation is y equals negative 1 on 3x plus 6. And you can see this point, 3, 5. That's the point we were looking at before. So yeah, guys, hopefully that's been clear. It's been a long one, but we've looked at an equation, how to go from an equation to a graph by plotting out points, joining them up. We only need 2, but we can use 3 as a check to make sure we haven't made a mistake. Graph to equation, using the graph, thinking about the form of the graph, y equals mx plus c, rise over run, getting a really good picture of that. Using coordinates, taking our, couldn't see c straight away, took 2 coordinates, used this method, we got a good feel for what's y1, what's y2, x1, x2. Changing y is just one y minus the other y, changing x is just one x minus the other x. Work out your number, then say the equation now looks like this, sub in some points to get your c value, and then finally how to look at parallel and perpendicular lines, and parallel, the gradients are the same, parallel, the gradients are negative and reciprocal, or just basically what's written down there. So good luck for week 5.